All right, so this is lab number 2, and today we're gonna talk about the wood compression test. All right, so of course you're gonna need a wood specimen. So if I move the camera over, and here we have a wood test specimen. As you can see, it is labeled RC, so that means it's red cedar. One of the things you want to make sure you do, because if you're going to run this test, you're probably going to have more than one sample. So you want to make sure your samples are labeled. If all is red cedar, you also want to make sure you label them number 1, number 2, and number 3 if you have 3 samples. All the things you might need are tools to measure your test samples. So of course you label your test samples and then you measure your test sample. You want to measure the cross-sectional area and the length of your test sample. So we're going to start with the cross-sectional area, the width. I'm measuring, see if y'all can see this. If you can read that, it's measuring about 1.4, and so it's probably 1.425 inches, right, for the width. And if I also measure the other side of the cross section here, I also have 1.425 inches, and then we need to measure the length. And of course the specimen is longer than this, so we're going to use a tape measure to measure the length. Half. So make sure you indicate or record your measurements. So 6.5 inches, 1.425 across, and 1.425 for the cross-sectional area. All right, so we have a square flat top, and this again is the compression testing machine that we are going to use. It's attached to that PC that you see there. So we're gonna set our specimen right in here. I have a flat plate at the bottom. We have a rubber pad, and we're gonna put the rubber pad down. The specimen, I'm also going to put a rubber pad at the top and another flat plate above the specimen. All right, so we want to make sure that the specimen is completely centered in the frame. All right, now to turn on the equipment, if you look closely, I'm going to grab the camera and move it around. On this side of the equipment, you can see the power button, right? So that button is the main power button for this machine. It's in the on position right now. So if you happen to be in here trying to use the equipment, make sure you remember that there is a power button on that end. Of course, you turn on your PC, it's already on. Here, the software that we're going to use for this is called the Navigator. And that's the icon right there. It's called a Navigator. So I'm gonna click on that. And also I should go ahead and mention, this is the readout panel. So after you turn on the main power button, this takes a little while to come on. It actually took about 3 minutes to come on today. So if it doesn't come on initially, don't think it's broken, right? Just give it some time and it'll eventually come on. So of course you're going to click on the Navigator button. And it's a Tinius Olsen test equipment. So that's coming up. And as you can see here, you can open, if you go to File, you can go to Load Test Setting. And if you open the Load Test Setting, there are several files that are in here for different tests. We are doing wood compression. So you would choose a wood compression test. There's one that says GE207. That's the course. So let's click on that one. Done. You can also go to File, Edit Test Settings. So this is where you make any detailed test information that you might need, right? We're using a flat specimen, right? Flat cross-sectional area. So you want to make sure that's included. Now you're going to have to, because this would allow you to input the width and the thickness of your specimen and the height of your specimen as well. We know for our test specimen, we have a 6.5 inches, so I'm going to change it right there. Let's see, other things that you can change. You can go to the machine control. You want to make sure you use the correct rate for testing, right? That's the speed. Again, we're using a constant rate of strain. So if you take a look at the machine platen there, the machine platen right here, it's going to come up, and it's going to come up at a constant rate of strain. Right, so as that comes up at a constant rate of strain, then we are really just going to measure the load. Right, so right here we have two different rates of strain, 0.15 inches per minute and 0.1. I'm going to go ahead and use 0.1. And let's see, what else can we change? If you want the reporting, the printout, you can input different factors here of what you want to see in your printout and also what you want to see on your graph, right? We are really looking at force and position. Position meaning the change in length. All right, so I'm going to click done. Yes, I want to change the settings. And you want to input at the very least, right? You want to make sure you input the width and thickness here, right? But again, I know we have red cedar, so I'm going to put RC. We're going to call this our first sample. Our width was 1.425 inches, so was the thickness. Right? You can input operator and lot if you want to. But now this allows you to start the test. And all we got to do now is make sure that our sample is in the frame correct. All right, so now we're back in our frame setup. So as you can see, I set it up and it's in there centered, but I still got a gap between this top platen, right? This top frame and the sample itself. So I need to make sure I bring that down. On the readout panel, you can hit the down arrow button right here. You see the down arrow? And if you use the down arrow, that'll bring the head down. So let's do that. Now you don't want to hold it all the way down and crush your sample, right? So bring it down slowly. All right, that's very close. So what I'm going to do is go ahead and zero all the forces, right? At the top, there's the zero buttons. But also I don't want to use the frame to bring this all the way down. You can also use the crank. All right. So the crank goes right here, and I believe if you go counterclockwise, it brings the head down. I can also pay attention to the load as I bring it down, and I would know when that hits. Look like I have contact. So that's good. So we'll set this down. And again, I zero all my forces, right? You zero the force, you zero the position, and then now we can start the test. And it's telling me that pump is not on, right? So I have to turn the pump on. Zero everything again, and then now I'll start the test. All right, so as you can see, right here, the test is running. Right, you see the live button there, so you see as the force goes up, the position goes up, that's the change in length. As you can see, if you actually monitor that, that is going up at a constant rate. and that rate is right about 0.1 inches. Right? If you apply a force to an object, three things could happen. Right? That object could remain static, right? Or that object could slide or translate, and also that object could rotate. Right? We certainly don't want any translation or sliding, or we don't want any rotation on this test, right? So our object has to be static, so therefore you got to make sure that you center this, your specimen, in the machine. You don't want any eccentric loading to cause any rotation, all right? And also with a static load on your specimen, your specimen could compress. Of course, that's what we want in this case. Your specimen could deflect, right? It could both. Your specimen could also shear. Your specimen could fracture. But I guess if you want to put all of those in maybe one word, your specimen is going to most likely deform, right? So you want to actually know the deformation behavior of the specimen in this case. All right. So during the test, we're going to take a look at how the specimen deformed, and after the test, we're going to see if we can note any shear or splitting that might happen, or the deformation that could happen in your test sample. At failure, there are generally five modes of failure that we want to look for. And those five modes of failure are crushing, where you have the grains actually crushing in the specimen. You also might have what we call a wedge split, where you have two cracks coming together, right, and forming a wedge, and that crack continues on. You can also have shear of your specimen. That you have a crack going across the grains, so that's shearing of your specimen. And you can also have splitting of your specimen, where you have the crack probably running almost along the grains of the specimen, right? And the last one, the fifth one, would be a combination of shear and split, all right? If you noticed that the compression test in this case is we are applying the load parallel to the grain. Generally, parallel to the grain is where you would see the highest strength of your test specimen or general wood specimen. So we always try to apply our load parallel to the grain. Now, safety. We built this frame and we're doing compression tests. This doesn't keep me safe right now, so I need to move it down just in case we have splinters and that start to fly away. Make sure you always keep this in place. If you're doing a tension test, you can keep it up here. If you're doing a compression test, it needs to be down. All right. So, of course, we're putting a load on the specimen, right? And what we're looking for is the change in length as well, right? So as you can see, the plot that this computer is going to show you is load on the ordinate axis, the y-axis, and position or change in length in the x-axis, the abscissor axis, right? Right now, we don't see anything happening, right? Because again, the scale is, the first mark here is 3K, which is 3,000 pounds. And right here is saying we right at 17 pounds. So therefore you can barely, you're not going to be able to see it because the scale is very large here. So we're way down here somewhere. But as you can see, we started to see it just a little bit coming up right here. So at this point, our force is going to start increasing rapidly, right? So you're going to have load in position. But again, as engineers, you want to change those to stress and strength, right? You're going to have to plot stress and strain based on load and position. As you can tell, our rate of strain is decreasing. So we're probably getting to the maximum force that the specimen can take. So we may start to see cracks in the specimen. Have about a constant rate there of the load, so we can go ahead and stop the test. So to stop the test, you don't want to click abort. You want to go to the next step. So if we move it on to the next step, that should stop the test. And then you want to click accept. This would save the test. Make sure you always click accept for the computer to save the test for you. And click OK to return the crosshead on the machine. And so the test should be now saved. And so if you go to Start, My Documents, and I believe it's called the Tech Test 781133. So that is our test. And if I open it up, you see it has force and position. Again, position is a change in length. So all you're going to do now is use the force, change that to stress, use the position or the change in length, and change that into strain, and then you can plot stress versus strain. You want to make sure you save this test as a different test, as another name, right? Because the next test you're going to run is also going to be saved under the same name. So you always want to make sure you save your test with a different name. All right. And let's show the test specimen. Take it out of the machine. All right, so now looking at the test specimen, on all of the 5 modes of failure that I mentioned, which one do you think this is? To me, it looks more like a crushing mode of failure, right? We would have the grains crushing at the top. Take a look at this test specimen compared to this one, right? You can clearly see a shear plane on this one, right? So we can probably call this mode of failure shearing, right? Where this whole block moves along that plane. But also if I flip it around, if you look right here, it looks like we have some kind of splitting as well going on, right? Along the grain. So maybe we can say the mode of failure for this test specimen is both shearing and split